Okay, good day, ladies and gentlemen. I hope you are still doing good. Welcome to the Technical Organization. Today we'll be doing a Doppler effect. Do you get me? We'll be doing a Doppler effect, the most simplest question in what? In physical sciences, paper one. Don't allow yourself to get these types of question wrong. Do you get me? So since today you are with me, I hope it will be a great lesson. This question six. They say an ambulance is moving away from a stationary listener with a constant velocity of 25 meters per second. Okay, they say what? An ambulance. This our ambulance. This our ambulance, ne guys. This our ambulance. Our ambulance, yeah, like this. It is moving what? It is moving away. It is going that side. From what? From a stationary listener. A listener. This is our stationary listener. Do you get me? Before, okay, the velocity of this ambulance is what? It is 25 meters per second. Do you get me? Since this listener is the stationary here, we know that when the ambulance is moving away, do you get me? The frequency of the what? Of the sound source will be the frequency of sound source will be what? Will be greater than the what? The frequency of the listener. Do you get me? Yeah, that's what I wanted to elaborate or illustrate. Do you get me? The siren of the ambulance emits a sound waves at a frequency of what? Of 550 hertz. Do you get me? The frequency of the sound source is what? Is 550 what? Hertz. Do you get me? So and then since here we know our velocity of this person, sorry, it is what is zero because he is stationary. Do you get me? This person, his name is Achieve. Do you get me? Yeah. The listener detects the frequency of this sound wave to be what? To be 512. The frequency now is the frequency of the listener is what? This 512,64. Yes. Now we have the frequency of the listener, we have the frequency of the source. I say the frequency of the source must be greater than what? The frequency of the listener. Indeed, 550 is greater than what? 512. Do you get me? So what they say, ignore the effect of a wind. Now they say state the Doppler effect in words. Since you have your examination guideline, don't get definition wrong. These are frameworks that is going to help you to achieve your distinction because we are working for level 7. Since physical science is very simple. Do you get me? Now, our definition said what? A change in frequency of a listener. Do you get me? Detected. You sorry. So a change in frequency of the sound detected by the listener. Do you get me? A change in frequency of the sound detected by the listener is doing what? Because the sound source and the listener have different velocities. Do you get me? Relative to the medium of propagation. They say a change, let me write it. They say a change in frequency. In frequency, the frequency of the sound detected by sorry, by the listener. Listener. Okay, sorry. By the listener because the sound source the sound source and the listener have what? Have different velocities. Velocities relative to the medium of propagation. Yeah. Okay, now they say use the given information to calculate the speed of the sound in air. They want the speed of the sound in air, since it is 6.1.2. When I say what, 6.1.2, do you get me? 6.1.2, we know that what, FL, frequency of the listener, is equal to what, velocity plus or minus via listener all over what, V plus or minus via source. And then here we're going to have what, F via source. This formula, it is on your formula sheet. Please just copy this formula as it is. Do you get me? You're gonna get a mark for doing, for copying that formula as it is. Now we are substituting. Do you get me? So when we substitute, now we can write the original formula that we're going to use. V, since the ambulance is moving away, here on the velocity of the source, we're going to have minus V, here on the velocity of the listener, we're going to have negative, and then V plus Vs Fs. Do you get me? When the ambulance or the sound source is going what? Is going away. Here above we have negative. When it is towards, we have a positive. Do you get me? So what is our FL? Frequency of the what? Of the listener. The frequency of the listener is what? 512,64. When I come here and substitute what? 512,64. This velocity we are looking is the velocity that we are looking for. Velocity of the listener is 0. I'm just writing 0 so for you to not to be confused. But even if you don't write anything, just write V. You get me? And then here we're gonna have V plus, here they say the car is moving with 25. And then what is our what? What is our Fs? Our Fs is 550. Here is multiplied by what? 550. Yeah, 550. Now we are applying mathematics. Do you get me? We have what? 512,64 is equal to what? Is equal to V all over V plus what? 25 multiplied by 550. Here we divide by what? By 550. We also divide by what? By 550. Do you get me? So when you divide by 550, normally I don't punch a calculator on things like this because it's going to give me comma, and then that comma is going to affect my answer. I will work it out. Here we have V plus what? 25 is equal to 512,64 all over 550. And then let's do what? Let's cross multiply. When we cross multiply, we're gonna say V multiplied by 550. Find that is 550 V. And then we're gonna say, since here we're gonna put a bracket, we're gonna say this one multiplied by this here will be 512,64 V. Then 25 multiplied by this, we're gonna say plus what? 512,64 multiplied by what? By 25. As I've said, I don't like punching a calculator. I will punch a calculator at the final answer. And then we're gonna take this 512 to the other side, and then it will be negative. When I say 550 minus 512,64, which will get what? 37. We're gonna get 37,36 V is equal to what? 512,64 multiplied by 25. Now we're gonna divide by what? By 37,36. Here we divide by 37,36. Our velocity, we'll find that is 512,64 multiplied by 25 divided by 37,36. Find our velocity. Our velocity is what? It is 343, 0.04 meters per second. Do you get me? The velocity of the sound on air. So now let's come here and answer this 6.1.3. They say if the ambulance moves away from the stationary listener with a constant velocity which is greater than 25 meters per second. Now on this scenario, on our drawing, the ambulance is still moving away as it is, but the velocity now it is greater than what? 25, but it's constant. Maybe the velocity is 600 meters per second. The velocity, the ambulance now is moving with 600 meters per second. Do you get me? And then they say how each of the following changes. When they say choose from increase, decrease, or remain the same. Then now they say the speed of the sound in air. The speed of the sound in air, it will remain the same. Why am I saying it will remain the same? The speed of the sound in air, or the velocity of the sounds, the velocity of the what? Of the ambulance does not affect our speed of the sound in air. Do you get me? And it will never affect our speed of the sound in air. The velocity of the source, it will never affect the speed of the sound in air. Even the velocity of the listener, it will never affect the speed of the sound in air. Now let's quote the frequency of the sound waves emitted by the siren. Do you get me? The car is now moving what? It's now moving with with 600 meters per second. But the siren, they didn't change. Okay, if you are moving with a car, with your dad's car, do you get me? And then your dad start to increase the speed. If he was playing a music, maybe the volume of the music was playing a music with the volume was maybe it was 5. Even if he increased the speed, you see, he drive it 180. Do you get me? The volume, or the volume of the what? Of the music, it is not affected. It will be still 5. The speed of the car does not affect the volume of the music. Do you get me? That's why here it will be what? Remain the same. Remain the same. I hope I explained it carefully. You? Yeah, it's English, you know. I hope I explained it kahle. Yeah, I explained it here very well. Okay, now they say the frequency of the sound wave detected by the listener. Okay, now here's another practical example. Now the speed of the car have increased, then the car is moving. Do you get me? The car is moving, it's going that side, the speed is increased, and then the listener is staying in this side, stationary. When the car is going that side, then the sound, when it will decrease, the sound that the listener is hearing, the frequency of the what? Of the listener is going to decrease. Why? Because the car is moving. It is like when you are doing what? Okay, when you are standing and then someone passing with his or a car. Okay, you are standing there and then I pass with my car. I'm driving my car. I hope you still remember the day that I found you on that road, you see, and then I pass you. When I pass you, because that day I was playing a music, I hope you were hearing the music, but when I start to travel, you see, for a long distance away from you, the volume of the music that you were hearing, it was decreasing. You see, this is the practical things. That's why you're gonna say what? We're gonna say decrease. I hope you understood me. Now let's go to 6.2. Then 6.2, they say the spectrum of a distant star when it's viewed from the earth is red shifted. This red shifted, they say, is the star moving away from or towards from the earth. Okay, my teacher that time when I was a student once told me about what Roy. He says it's Roy. Yeah, like this. I can't pronounce it. Red, orange, yellow, green, blue, indigo, and what is the V for? Ish. Sorry for this, but I will confirm it. I will write it on the comment section. The V. These are the lights you see. You see the colors: red, orange, yellow, green, blue, indigo. What's the V for? Yo, I forget that, but I will confirm it. Do you get me? So, since they say the spectrum of the distance of the is viewed on the Earth is red shifted, do you get me? Red shifted. We know that normally if it is red shifted, it is away. These things I just wanted to elaborate something for you. Do you get me? Because we have something that is going this side. Do you get me? When this away, we know that when something it is what it is away, the frequency is what the frequency of it is low. Do you get me? And then means that this thing is for what? This is for frequency, and then this for the, we have what? A threshold, a wavelength, what. Do you get me? So now here, since they are okay, we're gonna use this thing of what? Of frequency. Do you get me? This is a wavelength here. A wavelength. Do you get me? And then here we know that since it is red shifted, when your frequency, okay, since here on the car, this person was hearing a lower sound, his frequency was decreasing when the car is moving away. You see, the frequency of this person was decreasing when the car was moving away. Do you get me? And since the frequency was decreasing when the car was moving what? Was moving away. Do you get it? The frequency of this person was decreasing when the car is doing what? Is moving away. Look here. The frequency, when something is decreasing, it means that it is going down or it is small. Since here the frequency is increasing from this point to this point. For example, when here we have what? We have 10. You say here we have what? We have 30 or 70. Do you get me? It means that in other words, the frequency of red is decreasing. When the frequency is decreasing, it means that it is away. I hope I explained it very well. It's away here. Do you get me? They say use Doppler effect to explain the answer of 6.2.1. This was the Doppler effect that I was using. Do you get me? 6.2.2. They say I must explain it using what? A Doppler effect. What are you going to say? You're gonna say lower frequency. By using this, because the frequency here is lower at red, lower frequency or what? Or longer wavelength. Since I've said this is for wavelength, if the wavelength here is what? It is 30, means that here will be what? It will be 100, because it's starting from this point to this point to the other side. So and then that's why I'm saying longer wavelength here on right. Do you see? Longer wavelength is detected. Do you get me? If you wanna say, if you're okay, it is 2 marks, maybe here we're gonna have 1, or just to be safe, just put this the other point. You're gonna say what? This lower frequency. Do you get me? This lower frequency correspond to the red what? Red shift. Do you get me? To the red shift of spectrum. Now we are done. I think it was the simplest question. That's why, and then I explained it very well. So if you have something to say or you have a comment, just put a comment or send a message to 071 55 20 691. Thank you a lot. May you please don't forget to subscribe. Ne? Just subscribe. Thank you. May God bless you. Have a great day.